Now what we're looking at is the idea of sketching graphs and labelling all key points and whatever else there may be. So the first thing we're going to have a look at polynomials. So we've got a linear graph, we've got a parabola, a cubic, a quartic, and then any kind of polynomial where n is odd. We'll have a look at n being even and things like that. Okay, so with this, y equals mx plus c, and we're going to look at some key points as well. So in y equals mx plus c, it is just a linear graph. So we've got a y-intercept to label and x-intercept to label as well. Maybe the gradient, don't know. Over here, with our parabola, we will always have a y-intercept there, and we'll always have a turning point. Sometimes we'll have x-intercepts as well as a y-intercept. If it's something else, our x-intercept and turning point may have the same coordinates. So you've got to make sure that you're labeling all of those and you label them with coordinates. So you don't write 1, you write 0 and 1 for that y-intercept, for example, or whatever the case may be. So remember to be able to find x-intercepts, you've got to factorise it, let it equal 0, or use the quadratic equation. To find a y-intercept, just let x equal 0 and ends up being c. Okay, cubics. So in this form, it'll look something like this. This is not a turning point, that's the point of inflection. Once again, it'll always have a y-intercept, and it will have one x-intercept. Sometimes though, our cubic ends up going, you see a different colour, it ends up doing something like this, depending on whatever it is. In which case, we still label all the points with coordinates. If we can, we label our turning points, but we can't always do that at this point. Okay, now we've got our quartics. So for these ones, they look a certain way, and we'll do 2 of them. So your quartic may look like this, very much like a parabola, and depending on whatever we end up with, it may do something like this. It may do something like this. We've got a point of inflection, goes down and then comes back up. There's a whole range. That's kind of what it ends up doing. So anything like that. If we've got n being odd, so it's 5, 7, 11, 13, whatever, it always has this general shape where it starts off in one direction and then goes off to the other. If we had, I'll draw it on the same set of axes, except I'll use purple. If we had y equals x to the power of n, and n was even, then it would do the opposite thing where it would go up and down. Sorry, where it would go down and back up. So it starts and finishes in the same direction, whereas the other one, the odd powers, start and end at opposite directions. And once again, we label our y-intercepts, we label our x-intercepts, we label our turning points as best as we can with the information that we've got. Now, can I scroll? Yes, I can. Okay, so that's our polynomials pretty much taken care of. So as well as that, we end up with other graphs. We have things like y equals, we have our square root functions. We also have y equals, that's where we've got power over half, whatever it may be. We've got y equals our hyperbolas, 1 over x, and we've got y equals 1 over x squared. So then with these ones, so remember with your square root function, we have an endpoint. So we have an endpoint there. In this case, it's moved over a little bit, so so we label it with coordinates. With this, with your hyperbola and your truncus, we have 2 asymptotes. Remember, lines that they approach but never reach. And once again, we always label these with equations. There's the do x equals 0, y equals -1. So we always label them with equations, and then if there's an x-intercept or a y-intercept, we label whatever they may be. If not, well, then we still label some points. Doesn't matter, we label 2 points. Likewise with a truncus, we've got our truncus here. So with this, we've got a horizontal asymptote and a vertical asymptote. Remember, label them with equations, and then also label the coordinates of any x-intercepts and y-intercepts. If there are any x-intercepts, we do that. And there's y-intercepts, we do that. So that's what we've got for those ones. So that's those graphs as well. So as well as that, then remember, we also have our sine and cos graphs. So we could have y equals sine of x, y equals cos of x, and I'll put in tan as well. Y equals tan of x. So our sine of x, cos and tan. So sine of x starts in the middle, goes that way. Cos of x starts at the top and has a cycle. Tan of x does this. So we've got to be able to draw those as well. Which other ones do we have? Then we've also got our exponential graphs. So we'll have things like y equals a to the x and y equals log a of x. So these ones, let's talk about some key points here. So here we'll have our turning points. Here we'll have a start point, an end point. We've got a turning point there. We've got x-intercepts. Here we've got some asymptotes to label. With this, good idea to mark the highest and low point, so mark the range, and then find the amplitude as well. Likewise for this, no amplitude for the tan graph, but there is, you will have to label start and end points and things like that as well. In terms of our exponential functions, well, we know that this will end up looking like this, depending on it, and then once again, label your asymptote with an equation, y equals, label your y-intercept. For your log, same deal. Go off, and we draw it, we label our x-intercept, and then also our asymptote with an equation. So they're the types of things that we've had a look at in terms of graphs and graphing different functions and things like that. So we've got a whole lot there to choose from. And key points and the key things to remember are we label intercepts, x and y, we label asymptotes with equations, and then sometimes we may have to label endpoints as well. But there's our graphs.